How does pressure affect the behavior of gases? Have you ever wondered what happens to a balloon when you squeeze it? The way gases react to pressure is fascinating and can be explained through some basic principles. Let's break it down together. At the heart of gas behavior is pressure, which is the force that gas molecules exert when they collide with the walls of their container. When you increase the pressure, you are essentially forcing those molecules closer together. This leads to some interesting changes in how the gas behaves. One fundamental concept to understand is the ideal gas law, which states that pressure, volume, and temperature are all interconnected. If you keep the temperature and the amount of gas constant, increasing the pressure will cause the volume to decrease. This means that as you apply more pressure, the gas takes up less space. However, real gases can act differently, especially under high pressure. When the pressure is significantly increased, gas molecules are pushed closer together, and their own volume and the forces between them start to matter. This causes the gas to behave in a way that is not predicted by the ideal gas law. The real gas law, or van der Waals equation, helps account for these molecular interactions and the volume occupied by the molecules themselves. From a thermodynamic standpoint, when you increase the pressure while keeping the temperature constant, you compress the gas. This leads to more collisions between the molecules, which in turn increases the pressure itself. If you keep the volume fixed and raise the temperature, the pressure will also rise because the molecules move faster and collide more forcefully. On the flip side, lowering the temperature will slow the molecules down and decrease the pressure. Understanding how pressure affects gases has practical implications. For instance, engineers must design pressure vessels that can safely hold gases under various pressures. Additionally, knowing how gases behave under high pressure helps explain why certain gases can turn into liquids when enough pressure is applied. This knowledge also plays a role in everyday life, such as how atmospheric pressure changes with altitude can affect our breathing and even the weather we experience. In essence, increasing pressure on a gas typically reduces its volume and causes it to deviate from ideal behavior due to the size of the molecules and the forces between them. Grasping these concepts is essential for understanding thermodynamics and predicting how gases will behave in real-world situations.